Question 8. Here I have the polar form of a conic section. In order to show off what is happening, I would like to turn it into the form r equals ed over 1 plus or minus e cosine theta, or alternatively r equals ed over 1 plus or minus e times sine of theta. E is going to be the eccentricity. D will tell us about the directrix. Remember that if E is between 1 and 0, it is an ellipse. If E equals 0, then it's a circle. If E equals 1, then it is a parabola. And if E is greater than 1, it's a hyperbola. The first thing I'm going to go after is making this term here a 1. So I'm going to divide top and bottom by 2. There's a trick that I use which is sometimes helpful, and in this case it is. On the top, I'm going to write my terms this way. Instead of writing just 5 halves, I'm already planning on splitting it up into one term that has an E and one term that has a D. I have 1, that's 2 over 2, plus 3 halves sine theta. So all I've done is I've divided top and bottom by 2, or if you prefer, I've multiplied top and bottom by 1/2. Now, notice that in this form I have an E here, I also have an E here. Since E is 3 halves, I'd like to have a 3 here. In order to create balance, if I put a 3 here, I also need to put a 3 there. Now 3 halves times 5/3 is still going to be 5 halves. So this is E, this is D, and here I have 1 plus E sine theta. Now that's the first part. I put it into canonical notation. Next, I need to identify the type of graph. Since E is greater than 1, this is going to be hyperbola. I also ask you to identify the center and vertex. For that, I think it is easiest to begin as if you're graphing this. I draw axes. I label one of them theta equals 0. It reminds me that this is polar graphing. I have sine. The pattern for sine is 0, 1, 0, negative 1. I go back to this form. In this direction, I've got 5 over 2 plus 0. So just 5 halves here. In this direction, I also have 5 halves. In this direction, I have 5 over 2 plus 3. That'll be 5 over 5, which is 1. In this direction, looking this way, I would have 5 over 2 minus 3. That would be 5 over a negative 1. That would be a minus 5. The way that hyperbolas work, the 3 positive numbers are going to form one wing of the hyperbola. The negative is going to form the other. So here I have 1, 2, 3, 4, 5, and then 1, 2, 3, 1, 2, 3. 5 halves is between 2 and 3. I have a point here, and looking this way, going back 5, I have this point. Now I expect that one wing is going to look like that. The other wing is going to look like that. I'm not going to go through graphing it completely. I'm just trying to get you to visualize what's happening so that you can see that the center should be right here. That's going to be 2 units above and below my vertices. They're 4 units apart, so 2 units away. This would be, in Cartesian coordinates, the point 0, 3. And that will be your answer. I've put it into canonical notation. I've identified the graph, and I've found the center in Cartesian coordinates.